Good morning, children. How are you all? Welcome to Sanvi e-learning services. This is Rajanna, your math teacher. Today we are going to discuss about linear equations in one variable. The second chapter, the name of the chapter is linear equations in one variable, right? The aim of the topic is knowing about linear equations and solving exercise 2.1, 2.2, 2.3, 2.4 and 2.5 problems. Okay. The aim of the topic is solving exercise from 2.1 to 2.5 problems and knowing linear equations. And the agenda, our agenda is linear equation in one variable, solving linear equations in one variable, and solving word problems. So this is our agenda. Okay. So first of all, linear equation. What is linear equation? So before entering into the topic, first of all, we have to understand what is an equation. Okay. What is an equation? So if you understand about the equation, then you can understand what is linear equation. Here see, observe the slide carefully. See here, it is given sum of 3 and 7 given. Okay, sum of 3 and 7. So sum of 3 and 7, it means 3 plus 7. Okay, 3 plus 7. Sum of 3 and 7 means it is equal 3 plus 7. Okay, 3 plus 7, we all know that it is equal to 10. Okay, 3 plus 7, it is equal to 10. Okay. And here see, sum of a number, sum of a number and 7 is given. Okay, here two numbers are given, 3 and 7. So sum of 3 and 7 means we have written as 3 plus 7, that is equal to 10 we have written. Okay, but here sum of a number and 7, that number particularly not given like this. We don't know that number. So generally, when we don't know the number, we take as x. Okay, so sum of a number and 7 means it is x plus 7. Okay, see, if we observe these two expressions, in the first expression, here only the number 10 is there. But coming to second expression, here one variable is there. Variable is nothing but any alphabet, x, y, z, p, q, r, a, b, c, like that. Okay, here the variable x is there. So here there is no variable, but here one variable is there. If there is no variable, it is called numerical expression. Okay, if there is no variable, it means if you have only a constant number, it is called numerical expression. And if there is at least one variable, then it is called algebraic expression. Okay, here one variable is there, that is x. So this expression is called algebraic expression. It means if there is no variable, it is numerical expression. If there is at least one variable, it is called algebraic expression. Okay, now our question is equation. What is an equation? Okay, let us see one example here. Here it is given sum of a number and 7 is equals to 12 given. Okay, sum of a number and 7 is equals to 12. Okay, so sum of a number and 7 means just now we have discussed x plus 7. Okay, that is equals to 12. Okay, so it means sum of a number and 7 equals to 12 means x plus 7 is equal to 12. Okay, now see here, observe the second statement and this third statement. So what you find the difference here? See, in this algebraic expression, here there is no equal symbol, just x plus 7 is there. But here x plus 7 is equal to 12 is there. Okay, So here extra equal symbol is there and 12 is there. Some value is there here. Okay. It means an algebraic expression contain equal symbol is called an equation. Did you understand? If an algebraic expression contain the equal symbol, it is called equation. See here, there is no equal symbol. It is we call this, it is algebraic expression. But here equal symbol is there, so it is called an equation, right? So this is the equation. Okay, now next to see here. So here the definition is given about equation. So already we have discussed what is an equation just now. Observe the definition. An algebraic expression contains equal symbol is called equation, right? So here x plus 10 is equal to 15. Okay, see here algebraic expression containing the equal symbol, so it is an equation. Y plus 5 is equal to 7. Here also equal symbol is there, so it is an equation. Like this, an algebraic expression contains equal symbol is called an equation. Okay, now come to the our topic. Now what is linear equation? Okay, our name of the chapter is linear equation. So what is linear equation? Okay, let us see the definition. If the degree is 1 of an equation, it is called a linear equation. If the degree is 1 of an equation, it is called a linear equation. Here see one more term we have got newly, degree. Okay, what is degree? Okay, what is degree? So let us see the example. Before discussing about this, first of all, you have to understand what is degree. All of you see the board carefully. See, I am writing here some algebraic expressions. The first one is we are knowing about degree. So here see x power 5 plus 6x cube minus 8x square plus 6x plus 10, right? So this is an algebraic expression. Okay, so we have to find the degree of this algebraic expression. See, remember children, degree is nothing but the highest power of the algebraic expression is called degree. The highest power in the given algebraic expression is called degree. Here see, if we observe the powers here, x power 5 is there, x power 3 is there, x power 2 is there. Here x power nothing is there. It means it is this power is 1. And this is constant number. So the power of any constant number is always 0. See, if we observe these all powers, so what is the highest power in this? Clearly, we know that 5 is the highest power, right? So the degree of this polynomial is, the degree of this algebraic expression is 5. Like this, if degree means the highest power. What is the highest power in the given algebraic expression? It is called degree. Let us see one more example. X power 4 plus 6x power 7 minus 8x power 10 plus 6x square minus 5. Now say, what is the degree here? What is degree here? Right, you are absolutely right. The degree is 10. Why? Because the highest power is 10 is there here. Okay, comparing to this all powers, x power 4, x power 7, x power 10 and x power 2. These comparing to this all powers, the highest power 10 is there. So the degree of this algebraic expression is 10. Okay. So degree is nothing but the highest power of the algebraic expression. Now let us see one more example. 3x plus 5 is there. 3x plus 5. Here what is the degree? What is the degree here? See the highest power. How much is the highest power? See here, x power, nothing is there. So you have to imagine 1. If there is no power for the given variable, we have to imagine 1, x power 1. And here 5 is the constant number. The power of any constant number is always 0. Right? Now see, what is the highest power in this? 1 is the highest power. So the degree of this expression is 1. Remember that if there is no power for the given variable, the power is 1. If the constant number is given, that power is 0. Okay. So comparing to these two powers, the highest power 1 is there. So the degree of this expression is 1. So like this, if the degree of an expression is 1, it is called linear equation. Okay. If the degree of an equation, if the degree of an algebraic expression is 1, it is called a linear equation. Okay. So this is brief introduction about the linear equation. So here observe the slide carefully. So what is given? If the degree is 1 of an equation, it is called a linear equation. Just now we have discussed what is degree. Okay. See the examples here. X plus 7 is equal 20 given. So here x plus 7. What is the power of x here? There is no power. It means 1. And here what is the power of 7? 7 is the constant number. It is 0. So comparing to these two powers, 1 is the highest power. So degree of this expression, degree of this equation is 1. Okay. And the next is a plus 5 is equal to 9 given. So here the power of a is 1 and the power of 5 is 0. So what is the degree of this equation? 1. Okay. So in these two equations, the degree always 1. So these are called a linear equation. Right. Now the next topic is very important. When we transpose terms, see, when we are solving the linear equations, we have to send the terms from LHS to RHS. Okay. So as our convenience, we will send the terms from LHS to RHS. Okay. So when we are transposing the terms from LHS to RHS, these points we have to remember carefully. Okay. See, when we are transpose the terms from LHS to RHS, plus quantity becomes minus quantity. It means they will become opposite. Plus quantity becomes minus quantity. Okay. Next, minus quantity becomes plus quantity. Minus opposite plus only. No. So plus opposite minus. When we send the plus quantity to RHS, it becomes minus quantity. And minus quantity becomes plus quantity. Okay, minus quantity becomes plus quantity. It means when we send the minus term to RHS, it becomes plus quantity. And into quantity becomes division quantity. Into opposite division. Okay, so into quantity becomes division quantity. And the division quantity becomes into quantity. The division quantity becomes into quantity. It means plus become minus, minus become plus, into become division, and division quantity becomes into quantity. Okay. So these 4 points you have to remember perfectly. If you remember this 4 points perfectly, you can solve the equations very easily. Okay. Let us see some examples how they will becomes plus becomes minus. So all of you observe these examples and look at the board. say children, first example, suppose 3x plus 2 is equal to 10 is a linear equation. 3x plus 2 is equal to 10. Here we want to send this plus 2 this side. Okay, we want to send this plus 2 this side. Okay, so what will happen according to our points? What we have discussed till now, plus quantity becomes minus quantity, minus quantities becomes plus quantity, into quantity becomes division quantity, and division quantity becomes into quantity. Okay, these 4 points we have discussed now. Now we are sending plus quantity. Plus quantity we are sending this side. See, listen carefully. When we are sending the terms from LHS to RHS, LHS RHS means this equal symbol left side value is called LHS. LHS means left hand side. This equal symbol right side value is called RHS. RHS means right hand side. Okay. Now see here. Now we are sending plus 2 from this side to this side. Okay. When we are sending this plus 2 from LHS to RHS, first of all, in RHS, what is the given number? That number should write as this. Okay. Then after we send this number this side. Now plus 2 we are sending this side. So what will happen when plus quantity send to RHS? It become minus quantity. No? So here plus 2 become minus 2. Right. When this plus 2 send this side, it become minus 2. Have you all understood? In the same way, now see one more example. Suppose 5x plus 6 is equal to 8 given. Okay. 5x minus 6 is equal to 8 given. Now see, we want to send this minus 6 this side. Okay. We want to send this minus 6 this side, RHS. So what will happen? Can anyone say? 5x is equal to. So when we are sending the terms from LHS to RHS, first of all, this RHS number value should write as it is. Okay, right side 8 is there. So this this 8 write as it is. After writing this RHS number as it is, then only we have to send this left side number right side. Okay. Now send this minus 6 this side. What will happen? It becomes plus 6. Why? Because when we transpose minus quantity to RHS, it becomes plus quantity. No, minus quantity becomes plus quantity. Okay. So when we send this minus 6 this side, it becomes plus 6. Right. Have you all understood? So now let us see into quantity how it becomes. Third example. Suppose here 3x is equal to 15 is there. 3x is equal to 15. See here 3x is nothing but 3 into x. Okay, 3x is nothing but 3 into x. This 3x we write as 3 into x like this we write no. So 3 into x. Now this 3 is the into quantity. When this 3 send this side, what will happen? Here x will be. X is equal to. Right side number 15 is there. Every time this right side number first of all should write as it is. After writing the right side number as it is, then only this left side number we have to send right side. Okay. Now right side number 15 we written as it is. Now this 3 send this side. 3 is multiplication here. Into quantity. 3 is multiplying to x no here. So when this 3 send this side, it become division quantity. It means when this 3 send this side, it become 15 by 3. Why? Because see, just now we have discussed into when we transpose the terms from LHS to RHS, into quantity become division quantity. Okay. So here also 3 is multiplying to x here. So when this 3 send this side, it become will divide. Okay. So 15 by 3. Now let us see division quantity, how it will become as into. Okay, suppose see here, 2p by 5 is equal to 10 given. 2p by 5 is equal to 10. Okay, now this 2p by 5, here what is division quantity? 5 is dividing here, right? This 2p dividing 5. So 5 is the division quantity. So when this 5 send this side, what will happen? Let us see here. 2p is equal to, right side number 10 is there, right, as it is. Here 5 is the division quantity. We are sending this side, RHS. So division quantity becomes into quantity now. So here 5 is dividing. When we send this side, it will multiply. It means here division 5 is the division quantity. Division quantity become as into quantity. It means here 5 is dividing. When we send this side, it will multiply. 10 into 5. Have you all understood? So like this, children. So when we transpose the terms from LHS to RHS, plus quantity become minus quantity becomes plus quantity, right? And into quantity becomes division quantity, and the division quantity becomes into quantity. Okay. Now I am going to ask you a question for you. Let us see how many members will say correct answer. See children, minus 3x is equal to 15. Minus 3x is equal to 15 is there. Okay. Now I am sending this minus 3 to RHS. Okay. So I am writing x is equal to, generally what we will think, when this minus quantity sent to RHS, it become plus quantity. So I am writing like this, 15 plus 3. When this minus 3 sent this side, it become plus 3. Okay. X is equal to 15 plus 3. I have written, I sent this minus 3 this side, and I have written the equation x is equal to 15 plus 3. Okay. Is it right or wrong? Okay. Let us see how many members will say the answer. If your answer is correct, show your thumb. If the answer is correct, please show your thumb. Let us see how many members say correct answer. If the answer is sent, what I have written, if that is correct, you show your thumb. Very few members are showing thumb. Okay. Let us see what is correct and what is not correct. And see, and one more thing I am writing here. One more answer I am writing. X is equal to 15 by minus 3. I have written two answers here. When this minus 3 sent this side, it become plus 3. One answer I have written. And when this minus 3 sent this side, it become 15 by minus 3. So now, who are giving the vote for second answer? Let us show your thumb. Who are giving your vote for second answer? For first answer, only few members are given the vote. Now for second answer, please show your thumb. If you vote for second answer, please show your thumb. Okay. So many members are voted for second answer. Okay. Let us see now. The correct answer is this, x is equal to 15 by minus 3. This is wrong. Okay. Why? Because see, when we are sending the terms from LHS to RHS, we have to see the relation between these two terms. Minus 3x is given. Okay. Minus 3x is nothing but minus 3 into x it is. Minus 3x is nothing but nothing but minus 3 into x. It means here minus 3 is multiplying, right? So when this minus 3 sent this side, it become division quantity now. So it become by minus 3. But don't think here minus 3 is there. When we send this side, it become plus 3 like that. Okay, remember that when we are sending the terms from LHS to RHS, we have to see the relation between the given two terms. Here minus 3x means minus 3 into x. Minus 3 is multiplying here. So when we send this side, it will divide. But don't send blindly. If minus 3 is there, so when we send this side, it become plus 3. When this minus 3 become plus 3, let us see. If the equation is given like this, see, minus 3 plus x is equal to 15. See, if the equation is given like this, when this minus 3 send this side, in this case, it become plus 3. Why? Because here see, minus 3 is the another quantity, x is the another quantity. Between them, plus symbol is there. No? This plus symbol is dividing these two quantities, right? Plus symbol is dividing these two quantities. So here minus 3 is the another quantity, x is the another quantity. So in this case, when this minus 3 send this side, it become plus 3. But here both are mixed here. Both are mixed. There is no variation among these two quantities. Okay, that is why this minus 3 become division quantity. Okay, if the minus 3 is like this, it become plus 3. Right. So very good, children. Most of the students said correct answer. Who have voted for second answer, please raise your hand. Who have voted for second answer, please raise your hand. Please, all of you who have voted for second answer, please raise your hand and turn your hand like this. All of you turn your hand like this. Appreciate yourself. Appreciate. Please, children, appreciate yourself. Why? Because you told correct answer. You have given correct answer. Please appreciate yourself. Right? Okay, very good. Now, I hope that you all understood what are the conditions sending the terms from LHS to RHS. Okay. Now, the next topic is, so we have discussed what is what is an equation and what is linear equation and what are the conditions transposing the terms from LHS to RHS. Okay. Now, all of you open exercise 2.1. All of you open exercise 2.1. If you have textbooks, you open and see in your textbook. If you don't have textbook, I already opened exercise 2.1 on the screen. So all of you observe carefully. Okay. See, in exercise 2.1, it is given solve the following simple equations. It is given that solve the following simple equations. So solving means the given variable. What is the given variable? That value we have to find out. Okay. Let us see how to solve them. One equation I am going to solve them. So you all of you listen carefully. See, the first equation is given. First equation is given. (6m) is equal to 12. Exercise 2.1. First question is given 6m is equal to 12. Okay, 6m is equal to 12. So we have to solve this equation. So solving equation is nothing but, so what variable is given, that value we have to find out. See children, variable is nothing but any alphabet, X, Y, Z, P, Q, R, A, B, C, L, M, N, like that. Okay. So here M is the variable. So this M value we have to find out. To find this M value, here 6 extra is there, no? Okay. 6 extra is there. If there is no 6, we can say directly M is equal to 12. But here 6 extra is there. Now this 6 we have to send this side. Okay. This 6 now send this side. What will happen? Now I am going to ask this question for Pujita. Pujita, please unmute yourself. Pujita. Pujita, please unmute yourself. Are you able to hear my voice? Okay, children. Now see here. Just now we have discussed. Okay. When this 6 send this side, first of all, this side number should write as it is. And see the relation between these two. 6m means 6 into m. It means here 6 is multiplying. When we send this side, it will divide. Okay. 12 by 6. Don't think like this. 6m is given. So we are sending this 6, it is plus 6. When this plus 6 send this side, it become minus 6. This is wrong. Okay. Here 6m, we have to see the relation between these two quantities. 6m means 6 into m. 6 is multiplying here. So when we send this side, it will divide. So 12 by 6. 6 1s are 6. 6 2s are 12. It means what is m value? 2 by 1. 2 by 1 nothing but 2. So m is equal to 2 is the answer. Okay, m is equal to 2. In the same way, now see the second question. Second question is given 14p is equal to minus 42 given. 14p is equal to minus 42. This is also same. 14p is nothing but 14 into p. 14 is multiplying here, right? So when this 14 send this side, it will divide. So p is equal to minus 42 by 14. Okay. So when we simplify this, here 14 1s are 14, 14 3s are 42. Okay. Now what is p value here? P is equal to minus 3 by 1. It's nothing but minus 3. Okay. P is equal to minus 3 is the answer. Right. Now the same way, now see third question. See. Third question, minus 5y. Minus 5y is equal to 30 given. Minus 5y is equal to 30. Now this minus 5 send this side. Minus 5 send this side. What will happen? It become plus 5. When this minus 5 send this side, will it become plus 5? No. Right. Just now we have discussed minus 5. When we are sending the terms from LHS to RHS, we have to see the relation between the two quantities. Here minus 5y is nothing but minus 5 into y. So here minus 5 is multiplying. Minus 5 is multiplying. So don't think this when this minus 5 send this side become plus 5. So when this minus 5 send this side, it become by minus 5. Why? Because minus 5 is into quantity. When this send this side become division quantity. So 30 by minus 5. So when we simplify this here, 5 1s are 5, 5 6 are 30. So what is y value? Y is equal to 6 and down minus symbol also is there. No? It means minus 6. Don't forget minus symbol. Okay, down minus symbol also is there and up 6 is there. So y is equal to minus 6. Okay. And the same way you do the fourth question, fifth question and see the sixth question. Sixth question is given n by 7 is equal to minus 3 given. N by 7 is equal to minus 3. here n is the variable. So this value we have to find out. To find this value, now we have to send this 7 this side. Now observe this. Here 7 is dividing to 7 is dividing to n. So when this division quantity sent this side become into quantity. So what will happen? Minus 3 into 7. Here 7 is dividing. When we send this side, it will multiply. Okay. So n is equal to how much? 3 into 7. 3 7s are 21. Minus symbol also is there. Minus 21. So n is equal to minus 21 is the answer. Okay. And the same way you do the seventh question. Now see the eighth problem. See, eighth question, it is given 3x plus 1 is equal to 16. 3x plus 1 is equal to 16. Okay, here the given variable is x. This value we have to find out. Okay, so first of all, this plus 1 send this side. When this plus 1 send this side, what will happen? It is plus quantity, so it become minus. Why? Because 3x is the other quantity, 1 is the other quantity. Between them plus symbol is there. So plus symbol is dividing this 3x and 1. Okay. So when this plus 1 send this side, become minus 1. So 3x is equal to, first of all simplify this, 16 minus 1. How much it is? 15. Okay. Again 3 extra is there. This 3 also send this side. Okay. When this 3 send this side, what will happen? When this 3 send this side, here 3x means 3 into x it is. It means 3 is multiplying here. Okay. So when we send this side, it will divide. Okay. X is equal to 15 by 3. Okay. Now simplify this. 3 1s are 3. 3 5s are 15. So what is x value here? 5 by 1 is nothing but 5. So x is equal to 5 is the answer. Right? In the same way, you do the 9th problem. Now, once see the 10th problem now. 10th problem. 10th problem is given 13 minus 6n is equal to 7 is given. Okay. So first of all, this plus 13 send this side. So here what is the variable? N is the variable here. Okay. So this n value we have to find out. To find this n value, 13 extra is there and 6 also extra is there, minus 6. So these two numbers we have to send this side. First of all, 13 send this side. Okay. So minus 6n keep here only. Now this 13 send this side. Okay. So it is plus 13 now. When we send this side, it become minus 13. Right. Now minus 6n is equal to, now simplify this, 7 minus 13. How much? 7 minus 13 minus 6. 7 minus 13 is equal to minus 6. Now this minus 6 send this side. Minus 6 extra is there. So this minus 6 send this side. So n is equal to minus 6 by minus 6. Why? Because here minus 6n is nothing but minus 6 into n. Minus 6 is multiplying to n. So when this minus 6 send this side, become division quantity. But don't think here minus 6 is there. When we send this side, become plus 6. Okay. We have to see the relation between the two quantities. Minus 6n means minus 6 into n. Minus 6 is multiplying here. When we send this side, it will divide. Okay. Now here minus minus cancel. 6 1s are 6. 6 1s are 6. So what is n value? 1 by 1. 1 by 1 is nothing but n is equal to 1. Okay. And the same way, children, you complete the remaining problems. Just all of you, once all of you observe the 14th problem. Once all of you observe the 14th problem. 14th problem is given. 14th problem is given 8x plus 5 by 2 is equal to 13 given. 8x plus 5 by 2 is equal to 13. So whenever given fractions, first of all, we have to take LCM and we have to simplify it. Okay. Here the denominator is 2. So LCM also we get 2. So after taking LCM, what we have to do? We have to multiply each and every number by LCM. Okay. So the first number is given 8x. So this 8x you multiply by LCM 2 plus, and the second number is given 5 by 2. Okay. So the second number 5 by 2 you multiply by LCM, that is 2 is equal to 13. So first of all we should take LCM and we have to simplify it. So here multiply it first. 8 2s are 16 and x also is there. It means 16x. 8x into 2, 16x. 8 2s are 16x plus, here 2 get cancelled. The remaining value is 5 by 2, that is equal to 13. Okay. Next. So here x is the variable. So one by one quantity we have to send this side. First of all, this 2 send this side. Here 2 is dividing now. 2 is dividing. 16x plus 5 keep here only. First of all, this 2 send this side. 2 is dividing here. When we send this side, we will multiply into 2. Okay. So what will happen? 16x plus 5 is equal to 13 2s are 26. Now again this plus 5 send this side. 16x keep here only. Plus 5 send this side. This plus 5 become minus 5. Okay. Why? Because we need only x value. So one by one term we are sending this side. So 16x is equal to 26 minus 5 is equal to 21. Okay. Now again 16 extra is there here. This 16 also send this side. Okay. So when this 16 bring this side, so 16x means 16 into x. 16 is multiplying here. So when we send this side, it will divide. So 21 by 16. Okay. Can we simplify this 21 by 16? No, we can't simplify. So x is equal to 21 by 16 is the answer. Okay, children, I hope that you all understood how to solve the given linear equations. So in exercise 2.1, I explained some problems. The rest of the problems you complete at your home. Okay. So total we have 16 problems in this exercise. Okay. I have explained some problems. The remaining problems you solve them. Okay. The remaining problems are homework. Okay. Thank you, children. Thank you all.
Dear students, please wait. You have physics class now.
Yes, good morning, children. Now the session will be physical science. Yes. Now I am going to teach you the topic friction. Okay. Be ready, all of you. Yes. Dear students, welcome to Trustma Online Classes, Islamabad. Now we are going to study the topic from class 8, friction. So now we have learned about force of friction. Yes, we know already about force of friction, which plays an important role in daily life. This force of friction we learn in the chapter force. There we learn that this friction plays an important role in our daily life. Yes. Now in this chapter, we are going to discuss deeply about friction. Now the first topic, force of friction and its types. So based on this, we are going to perform one activity. So listen carefully. So the first one, identifying the forces acting on a body and effect of frictional force. So now look at the picture carefully. Now you are observing the one book and it is placed on the floor, on horizontal floor. Now this is the take as a 1, this is a 2 and this is a 3. Yes. Here gently push a book on horizontal floor. We are pushing this book on this horizontal floor. So what will happen? What do you observe here? Here, after pushing this book, you observe that the book moves for a certain distance. Yes, the position of the book is here at first. After pushing, the position of the book changes here. So here, the book moves for a certain distance and stops. Yes, here, the speed of the book gradually decreases and after some time it stops. Yes? No. Here, the book moves certain distance. Here, after some time, the book will stops because here the speed of the book decreases gradually. That's why it stops after some time. Here, why does the book stop after covering some distance? Here, the friction of the surface of the table restricts the motion of the book. Yes, at first the position of the book is at one side of the corner. Yes, after one push, it travels some distance and it stops after some time at the another corner of the table. Yes, here the friction of the surface of this table, or you can say this as a plan. Yes, here the surface of this table restrict the motion of this book. So that's why the book has stopped after some time. Here one more question. Why does the speed of the book change gradually? Yes, here when the book is pushed, continuously the speed of the book is changed. Finally, it is stopped at some point. Here, I'm asking that why does the speed of the book change gradually? Here, the friction obstructs the motion of the book. Okay, here the friction obstructs the motion of the book. So, the speed of the book change gradually. So that's why the book has stopped after some time. The speed is decreases continuously. Here I am saying that because of frictional force applied on the book by the surface of the table, the book has stopped after some time. Here the speed of the book changes gradually. So here, when we push the book, it moves with some speed. Yes, it travels some distance from one corner to the another corner of this plan or table. So when it is traveled some distance, is the book moving with a uniform speed here? No. It moves in non-uniform speed. When it is travel from one place to another place, the speed of the book changed continuously. Here, we can say that it moves in non-uniform speed. Here, uniform speed or uniform motion, non-uniform motion means, we know uniform motion means change in time. Yes, with respect to the object, speed here. Yes, we can say that here, equal distance in equal intervals of time. That is known as uniform motion. I'm saying that equal distance in equal intervals of time. So that one we can say that uniform motion. Here non-uniform motion means equal distance in unequal intervals of time. So here the book travels in non-uniform motion. So here we know that non-uniform motion of a body takes place only when a net force acts on it. When the non-uniform motion of a body takes place, when a net force acts on it. So here on the book, net force is acting. So what is net force? I'll explain you now. Here on the book, when we kept on the table, on the surface of the table, how many forces act on the book when it is placed on this table or surface of the table or floor? Yes? Here, there are 4 forces acting on the book on motion, such as here weight of the book, normal force, force and friction. All these forces are acting on this book. Now see, here 2 forces act on the book in vertical direction. Yes, 2 forces acting on the book vertical direction and 2 forces acting on the book in horizontal direction. Look at here. I said that 4 forces are acting on the book. In those, one is the weight of the book, or we can say that gravitational force. We can say it as weight of the book or gravitational force acting vertically down here. This is. It is denoted with W. So this is one of the force acting on the book vertically down. Remember this point? And now, here, one more force acting on the in vertical direction. That is normal force or reaction force. Yes, this is applied by the surface of the table, or we can say that the floor. That is acts on the book vertically up. It is denoted with M. So in this direction. Yes, here gravitational force is acts on the book in the vertically down, and this normal force applied by the floor vertically up. Here these 2 forces are acting on the book in vertical direction. So here as there is no change in motion of the book along the vertical direction, the net force acting on the book in the vertical direction is 0. Yes, so on the book, one force is acting vertically downward, that is gravitational force, and normal force acting on the book vertically up. So because of these 2 forces, there is no change in motion of the book along the vertical direction. The book is at rest. Yes, so here the net force acting on the book in the vertical direction is 0. These 2 forces are normal force and gravitational forces are cancelled out each other. These 2 are in opposite direction. Yes, so acting in the same direction, that means in vertical direction. So here the net force acting on the book is 0 because the state of the book is rest. So we can say that here gravitational force minus normal force equals to 0. So simply we can say that gravitational force equals to normal force. Here gravitational force and normal force are equal on the book. So that's why the book is at rest position. You can see that net force is equals to 0. Now, what are the forces acting on the book in the horizontal direction? What are the forces acting on the book in the horizontal direction? Here. So in vertical direction, gravitational force and normal force are acting on the book. Here, in the horizontal direction, the speed of the book is changing continuously. Yes. So when we push this book, the speed of the book is changing continuously. That means it is decreases. So here its speed decreasing gradually in the horizontal direction. So here we can say that the book has acceleration opposite to the direction of motion. Okay, I'm saying that here, listen carefully. This point is very important. The book has acceleration opposite to the direction of motion, which we call deceleration. Because here the direction of the motion is in opposite direction. So we can say that this is the deceleration. Here on the book in horizontal direction, the acceleration of the book and the deceleration of its motion are acting in opposite direction. So, what is the net force acting in the horizontal direction? Here, F minus F. I'm saying that here capital F minus small f here. That equals to 0. Here capital F means force and small f means friction. Yes. Here, these two, force applied and here friction is also applied on the book. Here these two, F minus F, capital F minus small f is the net force acting in the horizontal direction. When we place the book on the surface of the table, so when we apply the force in this direction, the frictional force is acting on the book in opposite direction. So here the net force is acting on the book in horizontal direction. So here small f is the friction and capital F is the force. So here when the speed of the body is moving in a straight line changes continuously. So here the book is travel in this direction on this floor in straight line path. So here the speed of this book changes continuously. So we say that the book has acquired an acceleration. Not only book, whatever the object we are taking, that object has acquired a acceleration. So here, by close observation of this activity, we can understand that the floor applies a force on the book against its motion. This floor applies a force on the book in opposite direction. Okay. So here, the book is also applies the same amount of force on the floor in the opposite direction. Here, floor is applying some force on the book. Yes, as well as the book. Yes, the bottom surface of the book is also applying the force on the surface of the table or floor. So here, these two forces are in opposite direction. Yes, so from this we can say that this floor is at rest. Hence, the net force acts in the direction of force applied by the floor on the book. Here, the force applied by the floor on the book is called frictional force or friction. Here, this capital F is the applied force and this small f is a frictional force. Yes. So here, because of these two forces, here these two forces are in opposite direction, applied force and frictional force. So that's why the book has stopped after some time. That's why the speed of the book changes gradually. So simply we can say that this as a frictional force or friction. Now, look at this lab activity. The aim of this lab activity, understanding the nature of friction and the concept of static friction. Nature of friction and concept of static friction. For this, the material required are one toy trolley and small wooden block and inextensible string, weight hanger and weights, pulley and table. Okay. Now, here, first of all, we need to take one small toy trolley and keep a small wooden block on its here. We are taking this as a toy trolley. You can observe this. This is a toy trolley here. And here we are keeping one small wooden block upon it. Here, this is a wooden block. Okay. Now, tie an inextensible string to the trolley and pass it over a pulley. Here, this is an inextensible string. So this is a pulley. Yes. Now, here another end of this string is fixed to weight hanger. One end is fixed to the toy trolley and another end is fixed to the weight hanger. Now we have to take one small weight here. Okay. Now, here Keep it on a weight hanger and observe the changes in motion of block and trolley. This is a block and this is a trolley. We are keeping one weight here to this string. Yes, now we have to observe the changes in motion of block and trolley. So here, what happens to the position of the block kept on the trolley? Here, as a rock and iron blocks are flat and make more contact with the surface of the table, they move slowly with adding of the weights. Yes, so here this block and toy trolley are make more contact with the surface of this table. So they move slowly with adding the weights. Now, does it fall or move along with the trolley? This block. This block will fall or move along with the trolley. Here we can say that simply yes. The limiting weight changes due to the difference in the sliding friction of the object and surface. Yes, here the toy trolley will move in the forward direction. Yes, in this direction when we are increasing the weights. Here we can say that the limiting weight changes due to the difference in the sliding friction of the object and surface here. So here what changes occur in the motion of the trolley and block? Yes, here we observe that when the weights are increased continuously, the trolley will move in the forward direction. The block will move in backward direction. Yes, so here we'll notice that the trolley with the block on it moves towards left with an acceleration. The block is at rest with respect to the surface of the trolley. So, but it is in motion with respect to the surface of the table. Yes, so here the block on the toy trolley is at rest according to the surface of the trolley. Listen carefully here. According to the surface of the trolley, the block is at rest. Okay, but according to the surface of the table, this toy trolley and block both are moving in this direction. So here, keep on increasing the weight on the hanger. We have to observe the motions of the both trolley and block. Here, the surface of the trolley, this surface of the trolley tries to keep the block at rest. Yes. So here this trolley surface tries to keep the block at rest. But here the force of friction by the surface of the trolley acts on the block in the direction of the motion. Yes, so this is the toy trolley and this is the surface of the table, and here we have one block, right? So when the weights are increased continuously, here the force of friction by the surface of this trolley acts on this block in this direction of motion. In which direction the toy trolley is moving, in that direction only, here the surface of the toy trolley applies a force on the block surface. Here the block also applies a force on the trolley. This wooden block also applies some force on the trolley in same direction? No, in opposite direction. Okay. And tries to move towards right. Here the trolley is moving in left side direction. Here this block tries to move towards right. So here you can observe in this picture. This is the direction of motion. Yes, but here the block tries to move in the right side direction. So here the two directions are opposite. So here we can increase the trolley's acceleration by increasing the weight on the hanger. Yes, when we increase the weights continuously, we can increase the acceleration of this toy trolley. So if we increase the acceleration of trolley gradually, at certain limiting acceleration or some limiting weight, yes, if we are continuously increasing the weights here, so at certain limiting acceleration or certain limiting weight, the block comes into motion in the reverse direction. Here the trolley moving towards left. The block comes into motion in the reverse direction. That means it tries to move towards right side direction. Yes, here the relative motion between surface of the trolley and the block. Yes. Now, here what happens when the experiment is repeated by using rock and iron blocks of the same mass and different masses? Yes, here when we are using the rock and iron blocks of the same mass and different masses, here as per this rock and iron blocks are flat and make more contact with the surface. So they move slowly with adding of the weights. So here, does the limiting weight change? If so, why? Yes, here the limiting weight changes due to the change in the sliding friction of the object and surface. Okay, now here given one point, apply some grease to the bottom of the wooden block and keep it on the trolley surface and do the same experiment. So what will happen now? Here at the bottom of this wooden block when we are applying some grease and when we are doing the same experiment? What will happen? So what happens to the limiting weight? What should we do to increase the limiting weight? Here, when grease is applied, the sliding friction is reduced. So the limiting weight changes. For a small weight added to the pen on the object moves. So we should add weights in the pen. Here, the force which opposes the relative motion of two surfaces of bodies in contact is called frictional force. So here, the surface of the trolley and the surface of the wooden block both are in contact. Yes, but here these two forces are in opposite direction. The trolley is moving towards left and the wooden block is moving towards right. The force which opposes the relative motion of two surfaces of bodies in contact is called frictional force. So here, in activity 1, the book moves with respect to the floor. Yes, so this friction is called sliding friction. Yes, there the book is moves with respect to the floor, or we can say table also. So here this friction is called, we can say that, sliding friction. So sliding friction is the friction which comes into play when the surface of one object moves relative to the surface of another object. Here, the book is moving on the table or floor. Yes, here the book is moves relative to the surface of the table. The surface of the book moves with the relative to the surface of the table. Okay. Okay. So remaining topic will continue tomorrow. Okay, children, the topic I want to stop now here. We'll continue tomorrow. Thank you.